Hi all, welcome to Go Classes. In this lecture, we will solve this question. This is a very interesting question. You can notice this table is given to you, this Cayley table is given to you, but this is partially completed. Means some entries are missing. Some entries are missing and we need to fill these entries. Complete this table. We need to fill these entries. It's like the Sudoku. Now, what information we have? We have this information that this Cayley table is for a group. So this information is very useful that this Cayley table, this is created for a group. Okay, so remember this information, this is very useful information, and with this information we are going to fill this table. This table we are going to complete. We are going to complete this table that is given to you. Okay, so remember this Cayley table is given to you, but this is partially completed and the question is asking you to complete the given Cayley table. And what information? With what information? This information that this table is created for a group. So you have a group in which you have 5 elements, E, A, B, C, D, star. This is some binary operation, and for this group we need to create this table and then we need to answer all these questions. Okay, so let's start. But before we start, let me tell you which important points we are going to use to complete this above table, to fill this table. Which points are we going to use? Means which properties of group we are going to use to fill this table. So let's see these properties we are going to use. We have already seen these properties in the lectures with proof. I have also given you the proof. Okay, in the lectures we have already seen these properties with proof. So let's see these properties. In Cayley table of a group, okay, remember Cayley table of a group. In Cayley table of a group, no element can repeat in any row. In any row, element cannot repeat. In any column, element cannot repeat. Means every element appears exactly once in every row, in every column. Okay, so remember every element will appear exactly once, not more than one, not less than one. Every element will appear exactly once in every row and in every column. So this property we are going to use. So remember this is very useful property. Let me tell you what we are saying. We are saying that in a group, we are talking about a group here. So in a group you can notice the Cayley table. In this Cayley table, this type of situation cannot happen. For example, X, Y, and let's assume A. Now, in this row, look at this row. In this row, this type of situation cannot happen that this element is repeating. This element is repeating. This type of situation cannot happen. This repetition cannot happen, I can say. In any row, remember in any row, this repetition cannot happen. Cannot happen in a group. Okay, so very simple. The proof we have seen in the lectures. Why this repetition cannot happen in any row, this proof we have already seen in the lectures. You can watch it. But the point is simple, that this repetition cannot happen in any row. Whatever row you take, this element, you can see this repetition cannot happen. No element can repeat in any row. Similarly, no element can repeat in any column. If you take any column, for example, let's assume this is A, this is X, Y. If you take this column, consider this column. Now in this column also you can notice this element cannot repeat. For example, if I put some element M here, now this situation cannot happen. Again, this repetition cannot happen. So similarly here, I can say repetition. Element cannot repeat in any column. I can say that element cannot repeat in any column. So element cannot repeat in any column, element cannot repeat in any row. This we have already seen in the lectures. The proof we have already seen, but these properties are we are going to use these properties. Okay, so very simple. No element can repeat in any row. Similarly, no element can repeat in any column. Okay, let's see another property that we will use. This property we will use if xy is equal to E. E is the identity element. Remember, E is the identity element. So let's assume that E is the identity element. Now I am saying that if xy is equal to E, then from here you can easily notice that from here x inverse will be y, also y inverse will be x. Why? What is the reason? Because you can see if xy is equal to E, what you can do, you can multiply with x inverse on the both sides. This value is same as this value. Okay, so you can multiply both of them with x inverse on the LHS. You can multiply this and this, you can multiply on the LHS with x inverse. So let's multiply with x inverse. Now you can easily notice, first of all, what is this? X inverse x. Remember, group is associative. Because this group is associative, so I can calculate this x inverse x first. This is E. What is EY? EY is same as y. That is equal to what is x inverse E? That is same as x inverse. So finally you can notice that x inverse will be y. And similarly, remember, you can also do y inverse. You can also check y inverse. Xy is equal to E. So what you do? You multiply this and this with y inverse on the RHS. Okay, means you do this. Okay, means you multiply this value and this value, they are same. So because they are same, so what you can do, you can multiply this with y inverse and you can also multiply this with y inverse. So if you do this, then what will happen? X, y, y inverse is equal to E, y inverse. Now because group is associative, we are talking about group. So group is associative, so I can calculate this first. I can calculate. So this will be E. What is XE? What is XE? That XE is simply, I can simply say that XE, that is simply X. So that will be, and what is EY inverse? That is Y inverse. So you can see Y inverse is X and X inverse is Y. So this is a useful property that we will use. So remember, if you have a group where this is some binary operation, this can be any binary operation. This need not be multiplication. Okay, this may or may not be multiplication. This can be any binary operation. So if you have a group in which you have this binary operation, if it happens that AB is equal to E, where is the identity element? Where is the identity element? So if this happens that AB is equal to E, if this happens, then remember A inverse will be B and I can say B inverse will be E. B inverse will be A. Okay, so this proof we have already seen. If this happens, AB equal to E, then A inverse is B, B inverse is A. Okay, and you can easily see this is the proof. Anyway, this proof we have already seen in the class also, in the lectures also. But again, I have told you. Okay, so these properties we are going to use. Now using these properties, we are going to fill this table. This table is given to you and we are going to fill this table. Let me tell you, filling this table, we will fill this table completely, but this is like a Sudoku. Okay, so in the newspaper, maybe you have filled this type of games come in the newspaper. Every day in the newspaper, this type of game will come. Okay, so where you will fill the entries. So this game is very similar to that. Or you can, maybe you have played the game of Sudoku. Okay, if you have played this. Okay, so if you have played this game, then in this game what happens? Let me tell you, in this Sudoku game what happens? In this game, very simple point that in any row, you cannot repeat the element. In this row, you cannot repeat any element. For example, if you write 9 here, now you cannot write 9 here. Okay, so you cannot repeat the element. If you write 9 here, let's assume 1 is here. Now you cannot write 1 here. So in any column, you cannot repeat the elements. Every element will come only one time. Every element is going to come only one time. Similarly, in any row, remember, this element you cannot repeat. This element you cannot repeat. Every element will come only one time. Okay, very simple. In any row, element cannot repeat. In any column, element cannot repeat. This type of game is there, Sudoku. Maybe you have played it. Okay, anyway. So the same property group has, I can say the group Cayley table also has the same property. We have already seen this, that group Cayley table, that will also have the same property, that in any row you can see that this element cannot repeat. Similarly, in any column, you can see this element cannot repeat. So in any column, every element will come exactly one time. In every row, every element will come exactly one time. So very simple. So this Sudoku. So this question is also very similar to the Sudoku. Now let's solve it. So let's start. First of all, you find the identity element. This table is given to you. From this table, one information is group, that this is a Cayley table for the group. This information we will use. Also, you tell me what is the identity element. In this, what is the identity element? You can see identity element means, what is identity element? Identity element means, for the identity element, remember, this row will be same as the header and this column will be same as the header. So you can see this is the identity element here. Remember, this is the property of identity element. We already know that in a group, if you have this identity element, if this is the identity element, let's assume, or I can say, let's assume this A is the identity element. If this is the identity element, then what will happen? Okay, so let's assume this is the identity element and let's assume these are the elements A, B, C, D. Okay, so if this A is the identity element, then in this situation, remember, this row, the row of identity element will be same as the header, Similarly, this column will be same as this header. So remember, it will be like this. this type of element will be called identity element. So here, if this type of situation happens, then this element is basically identity element. So here you can notice in this table, you can easily notice that this row is the same as this header E, A, B, C, D. This row E, A, B, C, D, this is same as this header. So I can say the identity element is E. We got the identity element. This is the first thing we got. Now let's see. Now let's see this entry, these entries. Let's fill these entries. First of all, you tell me, can I put D here? Can I put D here? In this entry, can I put D? See, remember your base set is this E, A, B, C, D. I am asking you, can I put D here? Very simple question I am asking you, can I put D here? Can I put D? D I cannot put because in this column I cannot repeat. So remember, I cannot put D here. So here I can say that D I cannot put. What is the reason? Because if I put D, then this repetition will happen in the column, and this cannot happen in a group. In a group, you cannot repeat any element in this column. You cannot repeat element. Okay, you can see in this column. Look at this column. In this column, you cannot repeat element. So I cannot put D here. Okay, similarly, I cannot put B here because I cannot repeat this element. I cannot put E here. I cannot repeat the element in a row. So what is the remaining? What is the, I can say here, you cannot put D because the repetition will happen. You cannot put E. You cannot put E because the repetition in this row will happen. You cannot put B because if you put B, then repetition in this row will happen. In this row, the repetition will happen. So you cannot put B. You cannot put A because if you put A, then also in this row, the repetition will happen. If you put A, then in this row, you can notice in this second row, in this row, the repetition will happen. So you cannot put A. So what is the only choice then? The only choice is that you have to put C here. And automatically now the only choice is that you have to put D here. So very simple. I hope you understood. This is the only choice. Now this is over. Now what? Now how to fill the remaining entries? What should I do to fill the remaining entries? Now you can apply, you can see the complete row of A is already there. So from here you can easily find the A inverse. Tell me what is the A inverse? You can see what is A inverse. Just apply the definition. I want to find A inverse. Let's assume A inverse is X. Then what it means? It means that A inverse is X. It means that if I do A star X, then that should be E. That should be identity element, right? So you can see, let's assume A inverse is X. Now if I do A star X, then that should be identity element. This is the definition of inverse. So you tell me for which element I am getting A star X equal to E. For which element I am getting the identity element. For which element this A is getting the identity element. See, here what should I write such that I get identity element? Here what should I put? What should I write here such that I get identity element? You can see this identity element I am getting if I put B here. Means if I put B here if I put B, in this if I put B, then I will get identity element. So I can say that A inverse is basically B. So I got A inverse is basically B. If A inverse is B in a group, if A inverse is B, then automatically B inverse is A. Okay, so if A inverse is B, then B inverse is A. Very simple point. You can see in this table, look at this table. In this table, you can notice this entry. Look at this entry. This entry is simply A star B. This entry and A star B is equal to E. This entry A star B is equal to E. I told you that if this happens, I told you this implies that A inverse is equal to B and B inverse is equal to A. Okay, so this we have already seen. So I can say B inverse A inverse B. Now how to use it? So you can see B inverse, I am telling you that B inverse is A. So what it means? Again, what it means, if B inverse is A, then I can simply say that B star A will be what? If B inverse is A, means the inverse of B is A, then B star A, by the definition of inverse, that will be identity element. So I can say this B star A, this entry will be definitely E. I got this entry will definitely be E. This is the identity element. So I got this entry also. Okay, now let's move on. So remember, I got this entry will be E. Now after putting this entry, you tell me what will be this entry and what will be this entry. See, 3 entries we got. Now in this column, look at this column, 2 entries are missing. In this column, if you notice, in this column 2 entries are missing. A, D, E we got. You can see B, C missing. Okay, B comma C are missing. So tell me, can I put C here? Can I put C here? No, I cannot put C here, because then in this row repetition will happen, because already this C is there. So I cannot put C. So what I need to do, I can put B, yes. Okay, and then I can put C here. So I got this column also. Okay, so I got, remember, I got this column also. I got this complete column. I got D here. I got D here. I got, so you can see E, B, C. E, this E we got, this B, this C. Okay, so this is what we got. And similarly, this is C we got. Okay, so this is what we got here. Now, let's move on. Now, how to fill the remaining table? Now, this is very easy. You tell me what entry will come here. See, D comma C cannot come here. I can say, in this, D cannot come, C cannot come, because D comma C are already in this column. In this column, look at this column. In this column, D comma C is already there. So D comma C cannot come. Similarly, B comma E is already in this row. Look at this row. In this row. In this row, B comma E is already there. So definitely B comma E cannot come. So I can say B cannot come, E cannot come. So what is the only entry that is remaining? So I can say only A can come. So in this, I can say A will come. Okay, very simple. Here A will come. So remember, I got that here A will come. Now, once this A come, now you tell me what should come here. So you can notice in this row, look at this row. Look at this row. In this row, you tell me what is missing. If you look at this row, then B, E, A we got. So C comma D are missing. C comma D. In these, C comma D will come. Definitely in these two, I can say either C or will come or D will come. Now you tell me. So here can I put C? I cannot put C, because in this column then repetition will be there, because already C is there in this column. In this column already C is there. So definitely I cannot put C. So I can say that here I need to put D and here I need to put C. Okay, very simple. So this is the final point that I got. That I got this entry also. I need to put D here and I need to put C here. Okay, so this also we got. Now you tell me very easily. You can tell me what entry this will be. See, look at these two entries. Now you can easily tell me what is these two entries. Look at these two entries. So you can notice DCA cannot come. So either E will come or B will come. Either E will come or B will come. Can I put B here? I cannot put B here, because in this row you can notice the repetition will happen. Already in this row there is B. So I cannot put B here. So definitely I need to put E here. And now automatically I need to put B here. So I got this E comma B also I got. Okay. So remember, I got this E also I got. Here I got E. Here I got B. Now you tell me the remaining. What about the remaining? For example, you can see in this row, if you check this row, in this row you can already BEC is there. BEC, that is already there. So I can say A comma D. This is the possibility, A comma D. Now you tell me A comma D possibility is there. Can I put D here? Can I put the D? Can I put it here? No, because already D is there in this row. In this last row already D is there. So I cannot put D. So I need to put A here. I need to put D here. So very simple. I got this, that I need to put D here. I need to put A here. Very simple. Now finally, these are remaining. So you tell me what should I put in these two? Okay, so only these are remaining. That's it. So in these two, what should I put? So you can already see that CBD is there. Already CBD is there. So here I can either put A or I can put E. So tell me. Now, can I put E here? I cannot put E here, because then this repetition is there. If I put E, then in this row, the repetition will be there, because in this row already this E is there. This E is already there. So I cannot put E. So what I have to do? I have to put A here. I have to put E here. So this is the answer I got. I have to put A here. I have to put E here. So this is the final answer that I got. This is your Cayley table. So the question is asking complete the Cayley table. We have done it. So I hope you enjoyed it. So this is very similar to Sudoku. So I hope you enjoyed this question. This is a very nice question, let me tell you. In the GATE exam, what they can do, they can give you this Cayley table partially completed. And then they can ask you these questions. So before answering these questions, first you have to fill it. Before answering these questions, if I ask you these questions, before that, first you have to fill it. Okay. So now let's see. Now the question is asking what is A star D? Now you have the entire table with you. So now tell me what is A star D? This is A, this is D. So A star D is C. You can easily notice that is C. This entry, remember this entry is basically A star D. So A star D is equal to C. So yes, that is correct. Next, what is A star A? A star A. A star A. That will be D. A star A. That will be D. Okay, so this is also correct. Next, what is B star D? So this is B, this is D. What is B star D? That is A. So remember this entry that you can see, this entry is basically B star D, and that is equal to A. Yeah, that is also correct. What is B star C? B star C, that will be D. That will be D. So I can say that B star C will be D. Yeah, that is also correct. Now let's see. The question is asking, implement group axioms for each element, find its inverse. Means for every element we need to find the inverse. So let's see. For every element, let's find the inverse. So the inverse of identity element will always be identity element. So you don't have to check. What is the inverse of A? That we have already seen, that is B. What is the inverse of B? That is already A. So these are already over. What is the inverse of C? Remember, in this, whenever you want to find the inverse of any element, then what you need to do? See, in the group Cayley table, if you have a group Cayley table, if I give you a group Cayley table, in this group Cayley table, if you want to find the inverse of, for example, how to find inverse of A. If you want to find inverse of A, all you have to do, just check in this row, in the row of A, just check where is, in this row, remember, in this row of A, you just check where is E, where is identity element. Let's assume identity element is here, and let's assume this is X. In this situation, remember, this X will be A inverse. Why this is A inverse? The reason is simple, because A star X is equal to E. A star, because if this E is here, if this identity element is here, let's assume E is the identity element. Let me assume E is the identity element. So if E's identity element is here, then you can notice A star X is equal to E. And if A star X is equal to E, then simply A inverse is equal to X, and X inverse is equal to A. So very simple. If you want to find C inverse, then you check this entry E. This entry E you check. Okay, just check this entry E. Now this entry is telling you that C star D is equal to identity element. This is the identity element. Okay, so from here, now from this equation you can easily notice that C inverse is D and D inverse is C. So we got C inverse D and D inverse is C. So this is the answer. So we got, find for every element we found the inverse. So this is also correct. All these questions we have done. Now the last question, that is G abelian? So how to check whether this G is abelian or not? In the Cayley table, let me tell you, when can you say that a group Cayley table is abelian? If you have a group Cayley table, when can you say this will be abelian? When can you say this group will be abelian? This will be abelian if and only if the table is symmetric. The table is symmetric. The table is symmetric. Symmetric means it simply means that ith row must be same as ith column. Ith row must be same as ith column. Remember, ith row must be same as ith column for all I. Okay, means first row must be same as first column, second row must be same as second column, third row same as third column. So I can say this Cayley table, this will be abelian if and only if table is symmetric. Okay, so you can see here, is this table symmetric? See, the first row is E, A, B, C, D. This is same as first column. First row same as first column. Let's see second row. Second row is AD, EBC. Second row is AD, EBC. Is this same as second column? AD, EBC. Yes. Next, third row, that is BECDA. Is that same as third column? BECDA. Yes. Fourth row, that is CBDAE. Is this same as the fourth column? CBDAE. Yes. Next, the last, I can say fifth row, that should be same as fifth column. Are they same? DCAEB. DCAEB. Yes. So I can say this group is abelian also, because first row is same as first column, second row is the same as second column, and so on. So you can notice this third row is the same as this third column. Okay, so fourth row same as fourth column. So finally I can say this is abelian also. So this is the complete analysis of this question. I hope you understood, and this is a very, very good question. This is a very beautiful question. In this question you can notice partially completed Cayley table was given to us, and from this partially completed table we created the complete table using this information group. Using the properties of group, we completed this table, and then we are finding the answer for the remaining questions. So this is a very important question. If you have any doubt in this question, if you have any doubt, please write your doubt in the comments. I will answer all your doubts. Don't keep any doubt. If you have any doubt, write your doubt in the comments. I will answer it. Okay. And also, please tell me in the comments, please tell me, did you like this question? This is a very brilliant, very beautiful question from the group theory. Did you like this question? Please tell me. Please put a comment and tell me the feedback of this question. Let me know, did you understand everything? And let me know, did you like this question?